Every single day, more than 10 million tons of food are processed in cutting-edge factories around the world. Behind this massive output are high-speed production lines and fully automated mechanical systems running non-stop, where capacity, speed, and precision are pushed to their absolute limits. In just a few seconds, tons of raw ingredients are transformed into finished products ready for distribution, achieving what humans alone could never accomplish without industrial machinery. In today's video, we invite you inside some of the most advanced food factories on the planet, where engineering and technological breakthroughs, many of which you may have never seen before, keep the global food industry running continuously and reliably every single day. Every autumn, nearly 3.4 million metric tons of apples pour into Washington, a large portion of which consists of utility-grade apples, not beautiful enough for store shelves, yet perfectly crisp and sweet, making them the golden ingredient for surprisingly rich and flavorful juice batches. Before processing, the apples are moved into massive recirculating water tanks, where a combination of aeration and dilute chlorine is used to knock off dirt and impurities. The cleansing process then continues with high-pressure water jets, which meticulously scrub every small crevice on the skin. After the rigorous cleaning process is complete, the fresh apples are transferred onto a dewatering conveyor system. Here, they pass through a system of rotating and vibrating rollers, which helps completely drain the surface water. This process is often combined with a gentle stream of warm air to ensure the apples are dried most effectively without compromising the quality of the fruit. Next, the apple mill operates as a cell disruption chamber. Inside, a rotating shaft is fitted with dozens of high-speed cutting blades or crushing hammers. As apples drop in, centrifugal force presses them against a stainless steel sieve, simultaneously crushing them and controlling the particle size. This specific design helps preserve the apple's full flavor without any metallic off-taste from rusty steel, minimizes heat generation, and protects the natural enzymes before pressing. Thanks to the intense pressure from a high-capacity screw press system, all the liquid is extracted from the mash. However, to achieve industrial-grade clarity, the decisive step is microfiltration using stainless steel pipes. At this stage, only small molecules like water and sugar can pass through. Up to 99% of microorganisms, enzymes, and colloidal particles are securely trapped on the surface. But did you know that the 100% juice label on apple juices today doesn't necessarily mean they are pressed entirely from fresh apples? Many products are actually reconstituted concentrates, or even blended with grape or pear juice to lower costs. Therefore, every drop of original, unadulterated apple juice is not only distinct in flavor, but also reflects a level of honesty that not every production line dares to uphold. In Mexico, Aloe Vera is an ingredient famous for its strict requirements regarding processing speed. From the moment it is cut from the field, the aloe must complete the entire processing stage in under 4 hours. Any delay will cause the enzymes in the leaves to spontaneously activate a degradation process, resulting in the gel turning brown and significantly reducing its biological activity. Starting this race against time, the leaves are moved straight to the production line, cleaned, and then dipped into a surface stabilization tank. This step is not merely soaking in water. It effectively creates an environment for immediate oxidation inhibition, helping keep the gel clear and slowing down decomposition. But to me, the most fascinating stage must be the cutting and filleting of the aloe flesh, as this step demands swiftness and the precise skill of material sensing, down to the millimeter. The aloe gel does not cling tightly to the rind but slides on an extremely thin layer of cells, only a few tens of micrometers thick. Therefore, the worker must simultaneously handle 3 key factors: positioning the knife close to the rind, maintaining an absolutely stable cutting angle, and controlling the knife's force, strong enough to fully separate the entire gel block, yet delicate enough not to pierce the flesh, containing all the expensive active compounds unique to aloe vera. Only the purest gel, which retains its biological structure and natural viscosity, is channeled into the extraction line for making gel or beverages. However, not everyone knows. Aloe vera products should ideally be consumed within a maximum of 1 to 3 months from the date of manufacture, because the longer they are stored, the more sharply the biological compounds decrease. Beverages can ferment, and gels will oxidize, even if their appearance remains completely normal. After harvesting, pineapples have a maximum of only 4 hours to be delivered to the factory before natural enzymes and sugars begin to soften the core. In the past, processing pineapples was a challenge due to the thick rind, deep-set eyes, and fibrous core. But today's state-of-the-art technology has thoroughly overcome these weak points, making the entire procedure significantly gentler. After being cleaned by high-capacity, swirling spray nozzles, workers only need to trim both ends to create flat surfaces. The delicate remainder is entrusted to the gripping mechanism and rotary blade system. Stable clamping pressure keeps the fruit perfectly centered, while the blade cuts precisely into the deep-set eyes while maintaining minimal material waste. The entire operation takes less than 5 seconds, replacing manual effort that could sometimes take tens of minutes. But that efficiency is not the final goal. On modern production lines, a single pressing cycle is sufficient to simultaneously strip the peel and core the center. Thanks to the self-centering blade system, the pineapple emerges from the machine as a cylindrical block, with a consistency error of only a few millimeters. From here, the pineapple is sliced and packaged entirely by machine, ready to enter the bags of pre-cut fruit, the highest consumption segment in the entire fresh fruit supply chain every day. Before becoming a sweet icon, the journey of the strawberry begins in the temperate fields of California, where farmers spend more than 6 months of continuous care before harvesting the first crop. Workers use small-tipped knives to remove the stem along the contour of the calyx, avoiding the white flesh inside, which bruises easily. Damaged berries are then discarded, since even a single bruised fruit in a batch can alter the flavor of the whole batch of jam and cause it to discolor more quickly. The next step is ultra-fast freezing at temperatures dozens of degrees below zero. This step is costly because it requires high-capacity freezing chambers running continuously, but in return, it is the key condition that allows all the water to crystallize into tiny ice crystals, helping lock in the bright red color, the sweet tart balance, and the fibrous structure. The strawberries are thawed slowly to prevent breakage, then cooked at a temperature below boiling. This heat is enough to concentrate the sugars without destroying the organic acids and aromatic essential oils, the elements that create the true strawberry flavor. During cooking, the sugar gradually seeps into each layer of fruit, giving the jam a supple, glossy texture while still preserving the visible strands of fruit, completely different from jams made with gelatin, which have a uniform, depthless structure. When the jam reaches the ideal consistency, it is poured into glass jars and sealed with tin lids while still hot. The tin lids are not just aesthetic. Once tightened, they create an almost vacuum-like environment that prevents microbial intrusion without the need for preservatives, and they do not react with fruit acids, so the aroma and flavor remain intact over time. With this rigorous process, in Europe alone, where annual strawberry jam consumption reaches up to 480,000 tons, whole fruit strawberry jam has become so popular that nearly every household keeps a jar in the kitchen. Right after sugarcane juice leaves the press, it still contains fibers, dust, and tiny organic compounds, impurities invisible to the naked eye. For this reason, a very small amount of lime is added to pull all impurities down to the bottom. This reaction works much like the clarification process used in Heineken's beer, or the clarification of Tropicana's fruit juice, using a chemical agent to bind and coagulate impurities, allowing the sugarcane juice to become crystal clear and ready for the concentration stage. As the juice passes through a multi-stage evaporator system, only the water disappears. The sugars gradually thicken into a golden syrup. Most major brands invest heavily in this stage because the evaporation rate and vacuum level directly determine the color, aroma, and stability of the final sugar. In the crystallization phase, seed sugar crystals are added as initial nuclei for the solution to cling to, gradually growing into well-defined crystals. The formation of the first sugar grains is similar to the way sea salt or crystal glass is cultivated, a single guiding crystal for the entire batch. Once crystallized, the mixture enters a centrifuge, where the crystals are separated from the molasses. Raw golden sugar retains 3 to 5% cane molasses, giving it a natural caramel aroma, while refined white sugar reaches 99.9% sucrose, precisely the purity level required by confectionery companies to ensure consistent flavor across millions of products. Even after centrifugation, the crystals remain slightly moist and prone to clumping, so they are dried to an optimal moisture level. For segments requiring absolute whiteness, such as sugar used for marshmallows or fondant, the crystals are even redissolved, filtered through multiple layers of materials, and centrifuged again to eliminate any remaining pigments. The final result is pure white sugar granules, so uniform that they look almost identical. But here's the interesting part: they were never truly identical. Natural variation between crystals is merely minimized through controlled crystallization and industrial grading systems, making them appear perfectly consistent to the human eye. Tomato sauce is among the most widely consumed vegetable-based products in the world, thanks to its limitless versatility. It appears in thousands of culinary recipes, but few people know that behind a seemingly simple bottle of sauce lies an entire industry operating under global standards. The journey begins when tens of tons of tomatoes are unloaded onto the factory's receiving conveyor to enter the washing stage. Here, the flume water system is considered the international standard. Water is pushed into a gentle, controlled current, strong enough to sweep away impurities, yet soft enough not to bruise the extremely delicate flesh. For tomato sauce, factories often prioritize the hot break method, rapidly heating the crushed tomatoes to a very high temperature to deactivate enzymes and preserve a stable thickness. The tomatoes are fed into industrial grinders, where steel blades turn them into a fine puree. Immediately afterward, the mixture is passed through sieves and membranes to remove seeds and skins, an essential step that ensures a smooth sauce, stable color, and long shelf life. The tomato puree is cooked in steam-jacketed steel kettles, stirred continuously to prevent burning. Meanwhile, onions and garlic are sautéed in sunflower oil. On average, a 1,000-liter batch of tomato sauce requires about 9 kilograms of onions and garlic before being blended with the tomato puree, along with salt, sugar, spices, and vinegar. For peanut butter, the process begins with shelled peanuts going straight into industrial roasters for 25 to 30 minutes. The temperature is automatically programmed to rise in stages, so the nuts dry evenly from the inside out. Once properly roasted, the peanuts pass through a soft shell removal system. Compressed air loosens the thin skins, and rollers separate the kernels without cracking them. A vibrating conveyor and suction fans remove the leftover flakes before an optical sorter scans up to 7,000 nuts per minute to eliminate burnt, unripe, or defective ones. Only the qualified peanuts move on to be ground by high-speed rotating mills, breaking down the protein oil structure to form a smooth, golden paste. At this stage, Salt, sugar, or vegetable oil is added through precision dosing systems accurate to the gram. The mixture is then heated in a closed cooking chamber to achieve the ideal consistency and gently pasteurized to extend shelf life while preserving the roasted peanut flavor. The hot peanut butter is then filled into jars ranging from 250 grams to 1 kilogram, sealed in a sterile environment, rapidly cooled to stabilize its texture, labeled, and sent through a final inspection using cameras and weight sensors. However, just half a bag of Doritos contains nearly 40% of the recommended daily sodium intake, about 3 times that of a regular serving of potato chips. Doritos has not only shaped global snacking trends, but also revealed the fine line between health and our dependence on flavor. So, how many bags of Doritos could you eat in a year? Before becoming the crispy golden chips inside every bag of Doritos, each corn plant goes through more than 4 months of meticulous care, from the moment the seeds are sown until the ears fully mature. Then, as autumn arrives, vast cornfields stretching for hundreds of hectares awaken to the thunderous roar of giant combine harvesters working tirelessly day and night. These machines are truly the heart of modern harvest season. Equipped with ultra-sharp stainless steel blades, they can automatically adjust their cutting height according to the terrain and plant size, ensuring precise cuts at the ears without damaging the stalks or losing kernels. Once cut, the corn ears are drawn into a sealed processing chamber, where gears, air blowers, and vibrating sieves work in perfect harmony to remove husks, silks, and stems, leaving each ear in its optimal condition. Immediately after harvesting, the corn is unloaded directly onto specialized trucks and transported to the factory in the shortest possible time. Thanks to modern technology, each harvester can process up to 140 tons of corn per day, drastically shortening the harvest period while preserving the freshness, sweetness, and natural starch content of every kernel. These qualities form the foundation of the smooth, elastic masa dough that gives Doritos their signature golden crunch. After leaving the fields, trucks loaded with golden corn ears line up and head toward the factory. Each massive truck bed is tilted to pour the corn onto outdoor conveyor systems, where thousands of tons of raw material begin their next journey. The entire area operates like one giant machine, bulldozers, conveyors, and air blowers working non-stop to evenly distribute the corn and keep the flow of material smooth and uninterrupted. From here, the corn is sent into the processing zone, ready for the next magical transformation, from raw kernels into soft, elastic masa dough, the very foundation of the legendary Doritos snack. As the corn travels along the conveyor belt, its first journey inside the factory officially begins. Each ear of corn passes through a high-speed husking system, where rough-surfaced rollers spin thousands of times per minute. Within seconds, the dry husks and silks are completely removed, without scratching or cracking a single kernel. Immediately after, the corn enters the kernel separation chamber, one of the most crucial stages of the process. Inside, 6 ultra-sharp steel blades operate in perfect synchronization at high speed, slicing the kernels off the cob with such precision that almost none are lost. Smart sensors automatically adjust the spacing between the blades, ensuring flawless performance regardless of the size of each ear. This production line can handle up to 6,000 ears per hour, creating a mechanical rhythm that's both powerful and precise. Right after the kernels are separated, streams of golden corn are directed straight into the cleaning system. Here, the kernels pass through a series of vibrating sieves, where controlled airflows and rhythmic shaking work together to remove dust, small stones, and fine sand. Then, they are thoroughly washed in high-pressure swirling water tanks, leaving each kernel gleaming and pristine as if freshly awakened. Next, the corn enters a specialized rotating drum that peels off the outer layer while removing any kernels that are too small, too large, or broken. This step ensures even cooking and lays the foundation for producing high-quality masa dough. Once cleaned and meeting quality standards, the corn is directed straight to the cooking area, where the real transformation begins. Giant mixing kettles cook the corn at around 190 degrees Fahrenheit, 88 degrees Celsius, for about 4 minutes, with a ratio of 660 pounds of corn to 20 pounds of water in each batch. This softens the kernels and breaks down their internal structure. The cooked corn is then transferred to 18 open soaking tanks, where it continues to absorb water for several hours until reaching the ideal moisture level. After soaking, the softened outer skins float to the surface and are removed, leaving only the pure kernels. The corn stream is then directed into an automated washing system, where high-pressure water jets and swirling tanks continuously clean and flush away any remaining husks or impurities. What's left are moist, smooth, and gleaming kernels, perfectly prepared for the grinding stage, where they will be transformed into a uniform, refined masa dough. The corn then enters the grinding stage, where it's crushed between two rotating alumina stones. At this point, about 20% white corn is often added to improve cohesion and create a smoother texture. Here, 3 key parameters are strictly monitored: temperature, moisture, and fineness of the dough. Even a deviation of just 1% in any of these factors can ruin the masa's life, its elasticity, and its ability to form that perfect crisp and airy texture after frying. From this masa, every Doritos chip is born with the same DNA, a perfectly balanced dough formula that Frito-Lay has kept secret for decades. Continuing down the production line, the perfectly prepared masa is pressed through metal rollers to form thin sheets, which then pass through a triangular cutter, capable of slicing up to 6,000 pieces per minute or more than 8 million chips per day. Immediately after, the small dough pieces are baked in a 3-tier high-temperature oven for 16 seconds. Just enough time to dry the surface while keeping the core slightly moist, ensuring the chips remain flexible yet structurally intact. This process is what creates the tiny air bubbles on the surface of Doritos, the hallmark of that perfectly crisp, signature texture fans love. To achieve the perfect crispness without burning, the cut chips are fried precisely for 55 seconds. During this time, the air bubbles expand one last time, creating that light, airy, and irresistibly crunchy texture. As soon as they emerge from the oil, the chips are drained of any excess oil and prepared for the seasoning stage, where the true soul of Doritos awakens, giving them their unmistakable flavor that sets them apart from every other snack out there. Before seasoning, Doritos chips are lightly sprayed with canola oil to help the coating stick, then sent into a massive rotating drum, where cheddar, parmesan, and a blend of spices are evenly dusted over each chip as they tumble gently against one another without breaking. In that moment, the rich, creamy cheese blends perfectly with the corn's natural sweetness, creating the bold, crispy, and irresistibly addictive flavor that defines Doritos. From this iconic base, the brand has expanded to more than 20 different flavors, from fiery barbecue to versions inspired by Mexican street food, transforming Doritos into a global symbol of creativity and bold taste. And after all those transformations, the Doritos journey inside the factory comes to an end on the cooling conveyor, where a burst of cold air quickly locks out moisture to seal in that signature crunch. At the packaging area, fully automated 14-head weighers ensure each bag reaches the exact target weight, with smaller bags holding around 28 to 30 chips and larger ones about 140. Before being sealed, nitrogen gas is pumped into every bag, not only to remove oxygen and keep the chips crisp for longer, but also to create a cushion of air that protects each piece from breaking during transport. Imagine standing in the middle of vast, lush cucumber fields, bathed in sunlight, stretching endlessly to the horizon. Welcome to China, the king of agriculture, where over 77 million tons of cucumbers are harvested every year, accounting for up to 80% of global production. However, production alone is not everything. When it comes to pickles, the United States is the true king, with renowned brands like Vlasic, Mount Olive, Clausen, and a pickled cucumber industry worth billions of dollars, closely tied to the fast food boom. With their sharp, salty flavor and irresistible crunch, stand out as a refreshing contrast to other pickled products like brined olives or pickled beets, offering a distinctive tanginess along with the added benefits of probiotics that help support digestion and improve gut health. Among over 100 varieties of cucumbers, only a few have thin skin, few seeds, are crunchy, and absorb flavor well, making them suitable for pickling. However, even within that group, only the high-quality 5 to 8 centimeters gherkin cucumbers, out of millions, are selected to create the tangy, crunchy pickles that are the soul of millions of jars worldwide. This explains why gherkin pickles, with a history spanning over 4,000 years, continue to exist and have become the golden spice, beloved globally and playing an essential role in the food industry. And every legend has a starting point somewhere. For pickles, the iconic sidekick that has won over millions of food lovers around the world, that journey begins in the sun-drenched, green cucumber fields. From May to July each year, the cucumber fields become more vibrant than ever as the harvest season officially begins. On the vast fields stretching endlessly, modern machines, large, precise, and powerful, have become the extended arms of farmers during the busy season. As the machine moves along each row of cucumbers, the harvesting head functions like a giant comb, brushing through each stem and guiding the vines into the machine. Inside, an automatic sorting system removes unnecessary leaves and stems while only keeping the cucumbers that meet the standards and transferring them to the conveyor belt behind. Unlike the modern potato harvesting machines from Grimm or John Deere, which are designed to dig up soil and separate potatoes from the ground with a capacity of up to 20 tons per hour, cucumber harvesting machines are built to be lighter and more precise, allowing them to harvest cucumbers without crushing the fruit, with a capacity of around 5 to 10 tons per hour. Traditional farming still yields stable cucumber harvests, but relies heavily on chemicals. In this context, organic farming, hydroponics, and greenhouses are gradually becoming the trend due to their ability to optimize yield, minimize negative environmental impacts, and address consumer concerns about pesticide residues and herbicides. Although technology has advanced significantly, it is the diligent hands of workers that still bring superior quality that machines cannot replace. Workers carefully pick each cucumber by hand, selecting those that are ripe and of the right size, then place them onto a moving conveyor belt attached to the harvesting machine or specialized trailer, helping transport the cucumbers to the storage containers quickly and gently. Manual harvesting, although much less efficient compared to modern machines with a capacity up to 15 times higher, ensures the finesse and precision that machines cannot achieve. After harvesting, trucks quickly transport the cucumbers to processing factories within 2 to 4 hours, preserving their freshness, crispness, and texture before embarking on the next secret journey, becoming the tangy, crunchy pickles that captivate the world. At the pickle processing plant, trucks carrying millions of tons of fresh cucumbers line up one after another, entering the raw material intake area. In modern factories, cucumbers are introduced into a closed-loop washing system, with multiple stages designed to ensure food safety and high input quality. First, cucumbers from transport trucks are poured into large indoor water tanks. These tanks contain clean, continuously recirculating water, often treated with ozone, diluted chlorine, or light brine to eliminate surface contaminants. The gentle water flow helps rinse off soil and debris while moving the cucumbers toward the conveyor belt without causing any bruising. Next, the cucumbers pass through a high-pressure multi-directional spray tunnel, typically 4 to 6 bar, where powerful water jets thoroughly remove dirt and bacteria. The water used in this stage is filtered and reused through a closed system involving mesh filters, activated carbon, and UV or ozone sterilization, ensuring both hygiene and resource efficiency. This process doesn't fully eliminate pesticide or chemical residues, which may remain on the fruit's surface. Therefore, to ensure consumer health and safety, factories must conduct strict checks in addition to following farming standards. Modern methods like HPLC and MS detect pesticide residues with high accuracy, with residue levels ranging from 0.05 mg to 5 mg per kilo, depending on the pesticide and regulations. Now here's where it gets interesting. There are two popular methods, each with its own secret formula for making pickles: natural fermentation for traditional and premium lines, and quick vinegar pickling for industrial products. First, for the natural fermentation method, cucumbers are sorted and then placed into large fermentation tanks, often positioned outdoors to take advantage of the ambient temperature, providing ideal conditions for fermentation. This method not only saves energy, but also promotes the growth of beneficial bacteria, which in turn creates the characteristic sour taste and increases the probiotic content in the final product. Each tank is filled with brine solution, a mixture of salt water and spices like dill, garlic, pepper, bay leaves, and others, depending on the unique recipe of each brand. The cucumbers are soaked in brine for 1 to 4 weeks, depending on the thickness of the skin, the type of product, and the desired flavor. It is the clever use of ambient temperature to promote the development of beneficial bacteria during fermentation, combined with the long soaking time, that is the key to creating the difference in flavor and crunchiness between the natural fermentation method and the quick vinegar pickling method. Once the fermentation period is complete, the pickles are carefully removed from the brine tanks and immediately transferred to the processing line for final cleaning and inspection. At this stage, each pickle is thoroughly rinsed to remove any excess brine, spices, or sediment that may have settled during fermentation. After rinsing, the pickles pass through a visual inspection system, either by trained workers or automated optical scanners, to detect and remove any defective or damaged pieces. Next, the pickles are sorted by size and shape using precision mechanical graders, ensuring uniformity in the final product. They are then transferred into filling machines, where they are packed into jars or food-grade barrels. Before sealing, each container is filled with a final brine solution, either the original fermented brine or a fresh one prepared under sterile conditions, to maintain flavor and preservation. Finally, the sealed jars undergo pasteurization in hot water baths or steam chambers, depending on the product type and shelf life requirements. This step helps to stabilize the pickles, ensuring food safety while retaining their natural crunch and probiotic benefits as much as possible. In contrast, the vinegar pickling method takes only a few hours, meeting the enormous demand with billions of jars produced worldwide each year, and a longer shelf life, all while being about 4 times cheaper than naturally fermented products for the same volume. And this is why this method is so effective. After being thoroughly washed and sorted, the cucumbers are placed directly into pre-sterilized glass jars or plastic containers to ensure absolute hygiene. Before the cucumbers are added, dry spices such as dill, garlic, mustard seeds, black pepper, and bay leaves are added to infuse natural fragrance. The cucumbers are then automatically divided into the glass jars. In addition to whole pickles, many products are also sliced into rounds, cut into chunks, or shaped in various ways, perfect for topping McDonald's or Burger King's burgers, or served with salads and sandwiches at chains like Subway and KFC. After the cucumbers are divided into jars, they are moved to the brine filling area, where the soaking solution is added to complete the flavor and preservation structure of the product. The key difference in this step lies in one essential ingredient: vinegar. For industrial pickle products, due to the lack of natural fermentation time, the brine solution must include vinegar, acetic acid, at a ratio of 5 to 10% combined with salt, sugar, and other spices. While the natural fermentation method requires refrigeration to maintain freshness and is typically consumed within a few months, vinegar provides an immediate sour taste. It also acts as a natural preservative, allowing the product to be stored at room temperature for up to a year or longer, making it more convenient for large-scale distribution in the global industry. For industrial pickle lines, this is also the beginning of the short fermentation process, which is strictly controlled for temperature and humidity, ensuring the product achieves a consistent flavor and standard crunchiness. So is naturally fermented pickled cucumber or quick vinegar pickled cucumber your idea of the perfect jar of pickles? The next step is pasteurization. Typically, the jars of pickles are placed in a continuous pasteurizer or high-pressure retort, where they are heated to a temperature between 80 degrees Celsius and 100 degrees Celsius for 10 to 30 minutes. After leaving the heat chamber, the product is rapidly cooled by passing through a cold water spray system, combined with high-powered fans placed along the conveyor belt, which helps quickly lower the temperature and prevent overheating or changes in the pickle's texture. Most naturally fermented pickles don't require pasteurization, as the fermentation process creates an acidic environment that inhibits harmful bacteria and preserves beneficial probiotics. Finally, the jars of pickles are placed on a conveyor belt and pass through an automatic labeling system. Each label clearly displays the product name, ingredients, production date, and expiration date. This step ensures that all jars have consistent, accurate, and compliant information for distribution. Pickles not only play a vital role in the global economy, generating billions of dollars in revenue each year, but also serve as a cultural bridge, connecting diverse culinary traditions and bringing the distinctive sour flavor of 4,000 years of history to kitchens around the world. And now begins the journey to the southern land, harsh yet abundant, where radiant dragon fruits are nurtured by sun, wind, and white sands. Every journey begins with the soil. Dragon fruit thrives best in loose, well-drained soil, rich in organic matter, with a pH between 5.5 and 6.5. That is why sandy loam and well-aerated gray soils become the ideal environment for roots to anchor deeply and unleash vigorous growth. Before planting, the fields are thoroughly plowed during the dry season to clear away weeds, especially persistent grasses like kogan or wiregrass, and root-eating pests that drain nutrients from young plants. If ignored, the cost of eradicating them later would rise sharply. Once the soil is ready, the next step is to set up the posts, the backbone of an entire dragon fruit orchard. Farmers usually use concrete or hardwood posts, about 2 meters long, buried nearly half a meter deep for stability. The part rising 1.5 meters above the ground is fitted with curved iron rods, forming a support for the canopy to spread. During scorching summers, concrete posts can absorb heat and damage the plant's delicate roots. To prevent this, skilled growers wrap the posts with layers of rice straw, dried banana leaves, or old burlap sacks. This humble covering acts like a suit of armor, reducing heat and protecting the young plants during their most vulnerable stage, until they grow strong enough to thrive. Once the posts stand tall like milestones, the choice of cuttings determines success or failure. Each cutting must come from a healthy mother plant, at least 6 months old, with dark green, plump stems about 50 centimeters long. It is estimated that in just 1 hectare, around 7,000 quality cuttings can double yields compared to planting inferior stock. The round, firm clusters of spines along each node are clear signs of vigorous growth, the foundation for an orchard to flourish in unison. Once the soil and cuttings are ready, the next step is to create space for the plants to reach upward. Dragon fruit is a sun-hungry crop, so farmers usually set the posts about 3 meters apart, wide enough for each branch to stretch toward the light. On 1 sow of land, roughly 1,000 square meters, over 100 posts are neatly arranged, forming bright, airy orchards where every branch has the chance to capture sunlight and photosynthesize to its fullest. When the cuttings are selected, they are planted about 4 centimeters deep. The core must be firmly embedded in the soil to prevent root rot, while the stem is tied securely against the post. Skipping this simple step means that just 1 strong gust of wind could topple the young plants. Typically, each post carries around 4 cuttings, creating the initial framework for the entire orchard. As soon as the cuttings are planted in the soil, water becomes the lifeblood that sets the entire journey in motion. The fragile young plants must be watered regularly, typically every 3 days, to keep the soil moist. When the scorching summer heat stretches on for months, farmers skillfully cover the base with a layer of rice straw or coconut fiber. This humble cloak not only keeps the soil cool and suppresses weeds, but over time it also decomposes into natural nutrients, quietly nourishing the plants day by day. For dragon fruit to grow strong and sustainably, it needs to be refueled in time. Farmers usually spread organic or inorganic fertilizer in a circle a short distance from the base, then cover it with a thin layer of soil and water it in. This method allows the roots to spread wider, absorb nutrients more efficiently, and minimize losses. Nature grants dragon fruit only about 3 natural harvests a year, but with artificial light, that number can rise to nearly 10. In mature orchards, rows of electric bulbs glow through the night, transforming dark fields into a sparkling galaxy. It is this light that compels the plants to bloom out of season, allowing farmers to control supply in line with market demand. When the flowers bloom, only a few strong ones are kept on each branch. Once they set fruit, The thinning continues until just one or two of the healthiest remain. This practice allows the chosen fruits to grow faster, with firm, glossy skins, sweeter flesh, and higher commercial value. Typically, dragon fruit takes only about 30 to 50 days after flowering to ripen, depending on the variety. This is considered remarkably short compared to many other fruits such as mangoes, oranges, or tangerines. To preserve freshness, dragon fruits are harvested in the early morning or late afternoon. An orchard can yield dozens of tons in a single crop, yet harvesting remains almost entirely manual. The reason lies in the fruit's unique growth. It clings tightly to the post, is surrounded by ears and spines, and ripens unevenly on each plant. Using machines to clamp, shake, or cut in bulk would easily bruise the skin, break the ears, or snap the stems, lowering the fruit's commercial value. For this reason, workers patiently move between rows, carrying small shears, bending down to inspect ripeness before cutting by hand. One hand holds the fruit firmly, the other makes a clean cut, leaving a stem of about 3 to 5 centimeters. Immediately afterward, the fruit is placed gently into baskets, ready to be taken to the collection point. After being harvested, the fruits are brought to collection points, stacked in plastic crates, and transported directly to the factory. During transit, temperature and ventilation are strictly controlled to prevent wilting or bruising, ensuring the fruit retains its quality before entering the processing line. Upon arrival, crates of vibrant red dragon fruit are taken straight to the reception area. Here, they are weighed and given an initial sorting by hundreds of workers before officially moving onto the modern processing line. Next, the dragon fruits enter a continuous washing system. Multi-directional water sprays combined with disinfecting rollers remove every trace of soil, sand, and dust, leaving the surface naturally glossy. The process is repeated through several washing chambers, like a double shield, ensuring each fruit is perfectly clean before moving forward. Leaving the wash station, the fruits are carried onto conveyor belts, where leaves, broken stems, and damaged fruits are eliminated. Automated rollers and electronic scales then grade them by weight and size, sorting them into uniform groups. At the end of the line, workers conduct one final inspection, keeping only those fruits that are flawless in both color and shape. Fruits that meet the standard are surface-dried, then neatly arranged into trays or paper-lined cartons. Each batch is wrapped with a breathable PE film or mesh bag, complete with traceability labels and export stamps. For demanding markets such as the United States, Europe, or Japan, the fruits must also undergo irradiation or hot water treatment to meet strict phytosanitary requirements. Finally, the cartons, each holding about 8 to 10 kilograms of dragon fruit, are sealed and placed into cold storage to preserve freshness. From there, refrigerated containers carrying dozens of tons are dispatched to seaports or airports, delivering this precious sweet flavor to consumers around the globe. Not limited to being exported as fresh fruit, premium quality dragon fruits are further elevated into a range of creative processed products. The most notable are crispy, naturally sweet, dried dragon fruit and refreshing, nutrient-rich dragon fruit juice. For dried dragon fruit, the journey begins with carefully selected crimson fruits, crimped at both ends and split open to reveal their juicy flesh. The thick green peel is neatly removed, leaving only the sweet white or red pulp inside. This pulp is then sliced into uniform pieces and arranged on trays before entering vacuum dryers for 14 hours, extracting moisture while preserving color, sweetness, and nutrition. Finally, the product is sealed in airtight packaging, where just 100 grams of dried dragon fruit equals more than half a kilogram of fresh fruit. ready to reach markets around the world. Dragon fruits of lower quality are by no means wasted. Instead, they are sent to processing facilities to be turned into refreshing juice. Here, the fruits are thoroughly washed, peeled, and then pulped to extract the fresh liquid. The juice is subsequently sterilized and bottled in glass or packaged in aseptic cartons. Thanks to modern technology, its natural flavor and nutrients are almost perfectly preserved. The result is a vibrant pink-red juice, rich in vitamin C and antioxidants, that has become a convenient and popular beverage in many countries.